Hey, hi everyone. In this video, we will see how we can leverage Databricks LLM options available, such as SQL AI functions, and then how we can deploy a RAG-based application in Databricks. So, as part of this video, we will cover the application side of LLM and not the technical aspect of LLM. So, however, to give a primer on what is LLM, LLM is basically a large language model which is trained on mass volume of data. So, this flow gives the high level, right? So, assume as simple, right? Like, say, let's assume we have three sentences: sky is blue, sun rises in east, and say Chennai is the capital of. Tamil Nadu, right? Then what we will happen is if somebody asks the question, right? Say the sky is, right? Then it will automatically based on the training data, it will predict the probability, right? Sky is blue. Okay. Now it's just a probabilistic machine. So now there might be a question, right? Like then how it answers our question. Say if I ask, right, who is MS Dhoni, right? Then it will try to answer, right? So LLM has two parts. So first one is the pre-training, which is just a prediction, right? It is very raw. So it cannot answer questions. It will just finish the probability. Say you ask a question and you stop there. Like say I like something, then it will write a story on its own. Now that is where the supervised fine tuning and then the post training phase comes, where there will be some methods like RLHF or DPO which will rank, right? So they will have a predefined set of questions and predefined set of answers will be there, and based on this, right, LLM basically understands the pattern and it tries to adapt itself, right? So that is the final model which you see, which allows you to answer the data, right? Now in terms of this demo, right, we will focus on the data engineering side of things, right? So for that we need some data sets with text data. So for that you can go to marketplace. So once you go to marketplace, you can search for review data set, and if you go to marketplace you can search here review. So if you search for review, see, we have a dataset which is free. So once you click on, let me show you another one. So this is the dataset which is getting used. But however, to enable that, right? So you have to see if it is free, and once it is free, you will be given an option. So you can click on this get instant access. Then it will be added as a catalog here. So as you see here, you will see a catalog which is added, right, using delta sharing. Similarly, for the RAG based application, we are planning to build a question answer endpoint where you ask a question about a Databricks documentation. It will give you the summary through a chatbot, right? So for that, we are using the Databricks documentation dataset. Again, that is available in your marketplace. So you can go to marketplace, search for Databricks. So this is again given by Databricks. So you will see, this is the one which has been enabled, right? Now let's see the common usage, right? Number one, right? So this data set, as I could see here, right, like we will have uh, a URL and then a review of the product, right? So say let us there. Now let us see, right, what and all we can do. So the first function which we will see is a analyze sentiment. So this function, what it will do is it will like give a sentiment like positive, neutral, mixed. These are the sentiments which it will give, and you can give a text. So here we have a review, and once we pass this review content, right, we can basically run this one. So once you run this, we get the review, right? So let's see some of the negative sentiments, right, as well as positive. I think it was mostly positive. Filter negative. I think nothing is there on negative probably. Yeah, I think few negatives are there. So um, so if you see here, right, it is somebody is complaining that that button is not good. So similarly you have the sentiment analysis in just a single SQL. Again, these functions are optimized for batch inference, so you can run this one and internally Databricks control, right? Say if you have 100k records or whatever the volume, they will split it in chunks and then it will be executed, right? So then assume we got the review, but however we need to basically further drill down, right? Instead of positive negative, we have to maybe classify the review, right? So that is why we have the AI classify function. So this function, what it does is based on the sentence, and then if you give an array of what you want to classify out of this, it will classify that, and then it will basically give the answer. Say for example, here I have given food is good, so it is mostly on the quality, right? Not on quantity. So it is given quantity. So food is ample. If I put this, I think it should give quantity, right? Because we have the quantity. So here you go. So it changes to quantity. Now, let us apply the same concept to the review. So this is a product review, right? So I want to classify the review based on certain tags, right? Say product quality, design and aesthetics, ease of use, functionality, then reliability, all these things, right? Now, if I run this query, I think there is some issue, right? Like this AI classify function doesn't include any functions with this brackets, etc. So I I also give another option where is a more advanced option we'll see in the bottom, which is AI query, which will also handle this scenario. Now, if you see the AI review text, right, again based on this classify, right, so this gives like a one step additional, right? So first step is you don't have any option to do the sentiment, it will give you directly the sentiment. Now let's say, right, we want to do further more analysis where we want to classify it, right? So if you see here, there are few classification, right, on aesthetics, and few are value for money, right? And see, there somebody has quoted the price, so it has given value for money, right? And somebody has basically quoted the like quality, right? So this is the AI classify function. So once we have the classification ready, right, the next thing is, right, we have the AI extract function. So what does AI extract will do, right? So this basically, again, it's a very good function. Like as LLMs are trained on pattern extraction, right, you can extract some features based on the data. So for this, right, we will use the Databricks data set, right? So this is the documentation data set where you can see they have basically extracted the content from the Databricks site. So handle bad records, right? So this is the one. So this gives you the text form of the actual document, right? So based on this, let's say we want to extract certain key components, right? Say I want to extract the navigation path, or what is the access mechanism, right? Or what is the portal we have to log in, or we have to classify, or we have to maybe put some tags, right? So these tags can, where it can be used is, assume you have a lot of document, right, and you want to initially filter down, right, the documents based on the tags. So this tags can be used, right? So once I give this, right, what it does is, like once you execute this function, if you see here, it has classified the future name, and then if there is any requirement it is given, and then it is given the path, right? So again, so these are out of the box functions, so you might see some variation, right, on like what it is inferencing. So but still, right, this function will gives you, right, as long as we are extracting some like known elements, right, it will be super easy, right? You don't need to write any code, or you don't need to even know LLM, right? Directly you create an extract function, give the content, and then give the future. That's all, right? Now, another one important function, which also we will use it in our RAG application, is the summary function, right? So generally, what will happen is, like you might have a lot of text document, and when you build a RAG-based application, right? So what is a RAG? So RAG is basically retrieval augmented generation, right? Where we will provide some additional context to the LLM so that it can answer correctly. Say for example, I mean, I will show it when I take the RAG section, right? For now you can remember, right, like RAG is basically achieved through some databases which are known as vector DBs, which will do a similarity search, right? So I'll explain in detail, but for the RAG, as a common uh, common convention, right? Say if you store a large amount of data, right? One two problems will be there. One is the quality of data. Number two is like the amount you pay. So that is where generally in RAG application, one of the strategies is to summarize the data. So this AI summarize, what it will do is it will summarize the data and will give you a summary of the document, right? So I have generated two types of summary. So this takes two arguments. One is the content, and another one is the number of characters or number of the words, right? So if you see here, I have given 25. So first summary will be around 25, and then I think the number is basically 25 is the token limit, so second is 50 tokens. So you could see first summary is little bit crisp, whereas the second one, right, extended summary is basically a little bit elaborative on what is being happening, right? And the summary is also making sense, right? So here they are trying to authenticate some Databricks services, right, like through SSO and other option they are given. So that is what it has been given in the uh, extended summary as well and the normal summary, right? Now the summary function is something which you will use later, and another one function is interesting function is this AI translate, right? So this is something which will be quite common use case, right, where you want to give the regionality to the people, right? Say if somebody don't know English or maybe French or whatever language, you might need to basically give the data in their language, right? So here what I have done is, as per documentation, they have only given 5 6 languages are supported, and one of the languages Hindi. However, I have tried in Tamil as well, and then the translation looks way good. So if you see here, I think while it is running, if you see here, right, like see does the job fancy, right? So it's काम करता है, and then it's almost similar, right? And even in Tamil, if you see, right, it is able to pretty much translate very well, right? So this is one of the functions, right, where you can give the regionality to the customer, right? Like say somebody might be interested in seeing that in their own language, right? So there is no boundary, so you can give it in their own language, so that can be helpful. I've seen all these functions so far, but there are some limitations. For example, in classify, right, you could not basically add a nested component, and in a extract, right, you cannot basically give a detailed description, right? So what if, right, you want to customize it further, right? So that is where AI query comes in, right? So let us see if this translate is completing, right? But anyhow, the output is good. So let us see the AI query. So what is this AI query? So number one is, so far whatever functions we use, it uses data. It needs Databricks serverless, and then it also uses the Llama models, right? The Llama open source models, and it is saying Llama 3.3, right? Is what it will basically leverage under the hood, right? Now let's assume, right, we have a lot of other functions. So if I go to the playground, you can see apart from llama, see llama is one of the LLM model. So apart from llama model, there are few from GPT, and then few from Gwen, and then few from like if you are having a paid version of Databricks, then you will have Anthropic and other models as well, right? So in case if you want to leverage that function, right, and do further more customization, right, then you can use the AI query function, right? So what is this AI query does? So it will basically take few of the arguments. So number one is a model, then there is a prompt. So here if you see here, right, the first, you remember this is the same prompt which I basically tried to give in the AI classify initially, and it failed because of the space and other characters, like there are some special characters were there. Now with AI query, I will be able to run the same function, right? And if you see here, right, it has categorized the things, right? So I asked it to categorize the things, so it has categorized, right, based on the functionality and then based on design, right? It was able to categorize the things, right? Like it is able to get the particular components, right? Like it is able to classify, right, design and aesthetics, functionality, etc. Now, but there is one more problem, right? Again, what we did not solve the actual problem, which as a DE, right, we will solve, which is converting the unstructured data to structured data, right? So here we have an unstructured data, right, where we have enriched the unstructured data, but still it is in unstructured form, right? So that is where, right, we have other options within the review text, right? So if you see here, we have few other options, like say request, which is the prompt which you want to give, And then we have model parameters and response parameters, right? Response format, I think this return type is not needed. So you have model parameters and response format. So what it will do is basically you can give the response format, like say I need a review category, and inside that I need categories and reason string, right? So this is something I need, right? So now even if you give this, right, the one catch here is, by default if you have 100 rows, all the 100 rows, when the LLM gives the response, right, it has to give in this particular format. But if it is not able to give, you will see that error because it is not finding that particular format, right? So it is trying to find the reasoning, right, content in the like particular category and reason we have kept, right? So the reason is not there basically, right? So for that there are a couple of options that, right, the function is failing, right, because the response is not coming correctly. That is because of this parameter, right? By default fail and error will be true. If you make fail and error false, if you see now we are getting the result, and wherever we have a error message, that is means in that, right, it is not able to parse the document, right? So it is not able to get the response in the given format, right? This is one way. So the another way of doing the things is basically you other options to define the prompt more clearly. If you see the previous prompt, I just said you have to classify out of this seven. But what if some review is there which cannot be classified to any type, right? So that is where in the next one, right, I have given written NA and none. If none of the category, it can be bucketed, and then I also made fail and error true, right? And additionally you see this par JSON, so that it will give a proper struct data type instead of like a variant data type instead of a string, right? So once I run this now, yeah, if you see here now, we are able to basically get a structured output with the reason of why it is choosing that category, right? So yeah, so with this, right, we are able to successfully basically create some meaningful informations, right, from our unstructured data and use it for our analytic use cases, right? The next thing is we also have other AI functions which are basically like AI mask. So this is again a very good function where it can be used for PAA, right? And one thing which I have to explicitly say here is, right, like I'm see, I we know like person email all these are good, so I gave Aadhaar, right, which is specific unification. I mean like identification number for India, and it is 12 characters in length. So I gave random more than 12 characters, and if you see, right, it is able to mask only that particular 12 characters, and this is because we have given ID colon, right? And now, right now, the final function is which is in beta, which is your PDF parsing, right? So earlier when we do PDF parsing, right, we used to use some third-party libraries, Python libraries, and then execute in driver as pandas, right? All these are gone now. So you have a very good function which is basically a parse document. So in order to test this one, right, we need to basically first create a volume. So what I did is I created a schema under my workspace, and here I have LLM rag as the schema. So inside that I created a volume. So inside that volume I have this document. So this document, right, AAPath document is a PDF document. So if you see here, this is the PDF document. So this is nothing but the documentation of AAPath document which is there in the Databricks, right, UI. So what I did, I just took that function and then I wrote it as a PDF, right? So if you see here, this is the, I'm reading it as a binary file, and this is the content of it, right? So it's just a binary content. Now save is to, I'm just saving it as delta, right? And what I did is, see, once you read the content as binary file, just give the content as input to this AAPath document, and you have some additional parameters like a basic text, and what it results back is it gives a variant data type. So if I go and check this variant, right, so it is like a variant, as you know, it's a new data type in Spark, performance efficient, right, natively written for semi-structured data. So how to parse this JSON, right? So if I basically query this data, right, if I give a select star from this data set quickly, if I give a select star, so if I give a select star, right, so this is basically a array, right? So if you see here, it has documents, it has elements, and within the elements, right, you have coordinates within the document and then the text, and it also takes whether it's a header or it's a normal text, right? All the content types are there, right? So what we are so this again will be helpful, right? Somebody can basically limit the text document, right, to only filter based on the header section, right? Because header will be more powerful rather than searching for a particular keyword line by line, right? So you also have that. So what I'm doing is I just read the like variant data, and I want the text component from here, right? So if you see here, there is a like if you unnest this array and go inside, you have the content component, and then you have the type component which will say whether it's a text component or a header, right? So I filtered for where type equal to text, and if you see here, right, it gives me all the documentation, right? So it gives me what this document does. So there's nothing but the text component which you see here, right? If you see here, a pass documents invokes that should be line, that should be, see, this is the line which is there, right? And it is giving that whole section, and so all this text, right, whatever you see here, it is able to extract. The power of this is, right, like you don't no longer need any Python function or anything, right? You don't need to write any third party libraries or anything for your extraction. And in fact, this AAPass document supports a lot of format. I have only taken PDF, but if you see, right, it says supports PNG, Word document, PPT, everything it is supported, right? I think this is in beta, but still a good option, like good thing to watch out for in the future, right? Now, other than the text components, right, you have the header sections, and then you have your footer sections, right? All these are basically extracted successfully. Now, before I move to the RAG thing, let me summarize. So in this section, right, we saw what is LLM. So there, LLM is nothing but a high trained mega model which predicts the probability. But with this probability, right, it will be of no use because we are like a question and answer we are asking, right? So what should we do? For that, there will be a post training stage will be there where they will use some other techniques like reinforcement learning, etc., where they basically have some users ask some question, and it will, like, LLM will be asked to add the response, and based on the response it will be again fine tuned, or like they call it as post training, where they basically have some like a curated set of questions, and they will train the LLM to answer those questions, so that it will adapt itself and give the probabilistic with some meaningful thing, right? Now, as part of this, we used the marketplace and we downloaded two data sets. One is a review data set and another one is your Databricks document data set. So first we see the analyze sentiment. So this is straightforward. It takes a text document and will analyze the sentiment as positive, negative, mixed, and neutral, right? And then we have classify. It takes two arguments again. One is your content text and then an array based on which it is classifying. And one thing is it can accept only normal characters. It doesn't have support the special characters. So we just converted this normal characters, and you can see it is giving the data, right? And next is extract. So this is like a tagging, right? So you have a volume, like bulk volume of documents, and you want to filter the document content, right, based on certain key features. So you can use this a extract component where you can give an array of features it want to extract, and it can extract the particular sentence from that, right? So it's like a pattern, right, which you will find in the document, and it will give that pattern, right? So it is able to basically give you the future name. Say for example, you can filter on the future name, right? Or you can filter by the authentication method, right? Or you can filter on any of this category, so that you can basically leverage this, right, before reading the entire document. So when you build a RAG, it's like similar to summary. You can also add some metadata based on this filter, so that user can also filter based on this, right? Then we have AI summarize. This will summarize the data. So given a content, it will create a summary on 25 to 50 tokens. Like one is the content, then second is the token, right? The number of characters. It again, token is again, it depends on LLM to LLM. You can like approximately you can consider like 75 words will be 100 tokens, something like that, right? You can take when you got translate function. So it takes a text and it will translate to the given child language. So see, if you see, it has translated to Hindi, and then it has also translated to Tamil very well, right? And we have the more powerful function which is AI query, where you have multiple options. So till now the above function doesn't allow you to customize, but this one allows you to customize the model, the prompt, the response format, right? And we also see, right, where we have multiple options where you have, if you basically by default, if any of the parameters is not giving the output correctly, like basically the response, if it is not coming in the expected format, then it will error out, right? So to avoid this, we have two options. One is fail on error false, which will basically suppress the error and then it will give you a result. But the issue here is it will give a response in a string, like a string format, right? Again, somebody had to parse that. So if you see here, this is again having all these special characters, right? So another option is to curate your prompt, right, and give explicit prompting. So here I have given return NA, right, if it is not able to categorize something, and with that, right, now with fail and error true also, right, you are able to get the response, right? And after this, we have other AI functions. So again, masking is there, and after that, we also have this parsing PDF, where with from a PDF, right, it extracts the text component. Now, the next thing is RAG, right? So, what is RAG? So, it's like assume now we have all this function we are extracted, right? Let's assume we want to build a chatbot, right? So, for building a chatbot, right, we need to give the context of our personal information, right? Personal information in the sense the data which belongs to any org, right? Like, see, the general ChatGPT will not answer on your documents questions, right? So, for that, generally, what we will do, right, we will build a RAG. So what is a RAG? So RAG is nothing but it mostly have some vector database, right? So vector database is like a normal database where you can search. Say if you put name like Somnath, right? It will give all the words which are having Somnath. This is a normal database. But whereas in vector DB, if you ask a question like give me uh, like cricketers like MS Dhoni, right? Then it will basically find out in the document the cricketers which are who are like MS Dhoni. Maybe it will give maybe Adam Gilchrist or Rishabh Pant, right? So who are, how it basically knows is these are again wicketkeeper batsmen who are very popular in recent cricket era, right? So normal DB will use only text based comparison, but a vector DB will do a context aware comparison, right? It will not try to map word to word. Instead it will try to map the context, right? So what we do as part of a RAG is we will basically create a vector DB. We will like create the vector DB for the Databricks document, and we will summarize that Databricks document, and then we will basically give the summary as a vector embedding, right? So once the vector embedding is embedded in the vector DB, when you ask a question, it will automatically basically convert that to an embedding, and then try to match the embedding to embedding so that it will get the context correctly and it will answer, right? So in short, if you don't basically follow this, a simple thing to remind is, see, for LLM you need to pass the context, and where does you get the context will come from your business metadata, and that business metadata when created into or converted into a vector DB, right, say Databricks Vector Search, it will allow you to basically do meaningful comparison. And so once you get the context from there, right, say I'm asking give me some example, right, say Databricks give me Databricks disaster recovery, right? So by default, if I go and ask in ChatGPT, give me Databricks disaster recovery, it will give some random thing. Whereas now, with this context, which I will show in this demo, you will see how it basically gets the corresponding documentation as part of the Databricks documentation dataset, and then pass that as input so that the response generated will be more meaningful. Right? So this will be the flow. So user asks a query, then that query will be converted to an embedding, and then it will search the embedding based on the summary, and that summary will be matched with the summary embedding which we already created in our vector DB. So what we do is, as per the preparation is, we created a vector search, and that vector search we will store the summary, right, instead of storing the whole data. I mean, it's again our choice. We can store the entire data as a vector search, but there will be lot of noise. So we'll store the summary, and when a user asks a question, it will retrieve the data based on the summary, and then that summary will be given as context to LLM, and then now LLM will answer. So I mean, let us see it in action, right? So first of all, right, I have created a table, right, which takes the same summary data sets, and then it creates a summary like not more than 100 words, right? So once it is run, so if you see here, this is how the summary will look like, right? So See, this is the original content. This is a summary with 100 characters on the same, right? Now the next step is we have to enable the change data feed feature. Why this is? Because we are going to use Databricks Vector Search, and Databricks Vector Search, right, will automatically use a DLT pipeline. So whenever this table is refreshed, you can basically run the vector search pipeline, so that it will convert these things into a vector embedding and then create a vector db on top, right? So this is all we need in terms of the data preparation, right? So once we prepared the data, then we have to create a vector db. So for creating a vector db, first we need a endpoint. So for creating a endpoint, you have to go to compute, and you have to go to vector search. So here, if you see here, right, I have already created a endpoint. So since community edition, right, only support one endpoint, I cannot create one more, but it's simple. You can just go to this one and then you can give the name of the endpoint. So once you create a endpoint, so this will act as an API, right? So when you want to query a vector search, you need a URL kind of sort, right? So this is like endpoint is like an address. Now for this is just a address folder, right? Now in this endpoint, we have to keep our vector DB, right? So how will you create a vector DB? So for creating vector DB, again, you can do it programmatically, but for this demo, right, video, a easy way to do this is go to your table, right, uh, where you have your data. So this is the data, right, where I have basically it will take some time. Yeah, so this is the same data, right, where I have the summary. So now if you see here, right, we have the summary. I think it is taking some time. Yeah, while the summary is coming on, right, like you click go here, you have an option to create a vector search index, right? So now you can give the index name. So that is the Databricks vector index, right, which I have given, and then you have to create a key column. This key column is again used by the pipeline, right? It creates a DLT pipeline. That DLT pipeline will ensure that whenever an update is automatic happening, it automatically updates the vector store as well, right? So this is made very easy, right? This looks, I mean, when I say, right, this looks pretty much simple, but this is a very tiresome process, right? Or else somebody has to ensure that the upsets of the vector DB are happening smoothly, right? So all these things are beautifully handled by CDF and the primary key here. So I have given ID as primary key column. Next thing is you have to have columns which needs to be added as part of the metadata, right? So you have two sets of columns. One is an embedded column for which it will do the embedding and it will search based on that. So there you have to give extended summary, because this is the summary which we need to embed as a vector, right? And other columns still we need to add, so that that will add as the additional metadata which we will pass it to our LLM for the additional context, right? Then you have triggered mode, continuous mode, right? When you have triggered mode, whenever you trigger that DLT pipeline, it will go and basically vectorize that whenever there is a change, right? So once you do this, now you go to Databricks vector, and I mean, once you basically click on create, you will get something like this, right? So if you see here, it gives you the source table, it gives you the endpoint, right? The endpoint which we have created already, right? That will be used, and I have 5,000 rows. Those 5,000 rows are there, and you have the DLT pipeline. This DLT pipeline is all self-managed by Databricks, right? Where it will basically index the process. Again, there are multiple options. So if you want, you can easily use this, right? You don't need to maintain the pipeline, right? Databricks does the heavy lifting. But in case, right, if you want to come up with your own embedding, right, instead of Databricks provided embedding, right? So in this case, we have given, say, we have given the embedding as Databricks GTE large embedding, right? So I'll show you where I have to give that. So once you click on create, right, you will give two things. One is this primary key, and then let me give you maybe test. I'll not create it, but I'll give all the things. So you will give the ID columns. You have to sync all the columns. You have to compute embedding. So you have to compute embedding for this, and then here only you will give the embedding model, right? So we are giving the Databricks GTE, right? This is the embedding model which you have to use, and you have to give the vector search endpoint, right, which you will use. So this is the exact setting which I gave, and once you give this and click on create, you will get the vector db, right? Now, so now we have a vector db where we have given our company specific information, right? So let's see, right, let us go to our query again, right? I mean, let us go to our notebook again. So Now, let's say, right, we have built this, right? The next term is we have to test the applications, right? So, LLM application. So, again, for testing LLM, right, there are a lot of frameworks are there, right? So, one of the framework which I have chosen for this demo is a LangChain, right? So, LangChain is nothing but a framework which will basically allow you to customize your prompt, your LLM model response, everything, right, in a programmatical way. One key place where it changes, it has a lot of integration. Say, for example, you can use Databricks model or any other LLM model, and you can change the model prompts response, right, very easily, right? Say, for example, Google Gemini will have its own way of, like, it has its own SDK, so there they will send the prompt in a different way. But for Databricks, right, again, Databricks has its SDK and it sends the prompt in a different way. But where LangChain changes, it will unify the interface. So you either you use Gemini or you use Databricks model, it doesn't basically change the behavior, right? Everything is one at the same. Yeah. So for testing the LLM, right, again, there are various frameworks. We are using LangChain. Why? Because it is like a framework where you can send a prompt, a format, a response for an LLM, right? We can suggest the LLM to send a response, and it has methods for everything, and it also has nice integration. So you can quickly like have one vector database, then change to a different vector DB and change to a different model, right? So Gemini API has its own SDK, Databricks has its own SDK. So, but when you use LangChain, it's just a one or two lines you have to change, right? Now, this is about LangChain. Basically, it's an Python library which will basically allow us to integrate various LLM models and then work with various LLMs to create LLM based chatbot application. Data, right, where you have this RAG summary, right? Now here, one of the things which we will ask is, right, we will ask about the disaster recovery, right? So you have this disaster recovery, right? So this is the document which has the step-by-step disaster recovery. Okay, I think it is taking some time to run. Okay, let it run. So yeah. So you have the disaster recovery here, right? So this is the disaster recovery which is given in the Databricks documentation, right? So they are given some steps for basically how to do disaster recovery, right? You have the options which are given here, right? Now let's say, right, we are basically asking, like, we are using LangChain to basically first we'll interact with the LLM without the RAG, and next we'll interact with the RAG and we'll see how the difference, right, how it differs and how the context matters, right? So for installing or for running the LangChain, right, you need to install these libraries: Databricks LangChain, LangChain Community, and Databricks SQL connectors. So once you install these libraries, you have to restart the environment. So now first step is you have to do two things, right? You need to basically create a model, right? So we are using Databricks model, so we are using the llama model. And temperature, right, temperature of very low number means it will be more deterministic. A temperature of very high, right, say 0 to 1 will be the temperature range. If it is around 0, then it is more deterministic. If it is around 1, it is very random. And token, maximum tokens is 250. That means the tokens will limit will be up to 250 characters, right? So now when I invoke this, see, I've asked for a disaster recovery, right, using Databricks, like like provide a disaster recovery step by step process for Databricks, right? So if you see here, right, it has some it basically when you give this, right, it gives some random data, right? It doesn't give you the particular content. And if you see here, right, it is also broken, right? So why it is broken for 250 lines? That is because we are given a Databricks, right, with maximum tokens as 250, right? So just to like give you what is this max tokens, right? So it will basically limit you. And again, right, you did not see what you are seeing here, right? If you see here, here, right, again it is more of, it is showing different set of info, right, like it is talking about high availability guarantees, control plane, all these things, right, whereas here it doesn't show anything on a specific, right, with respect to what is there in the actual documentation, right. Now let us do the same thing. What we are doing is, see, we gave the vector search, right, so first we basically import the vector search, and this is the name which we have already created, and we use this method, and then we first invoke the context. So once you invoke the context, right, so if you see here, we are getting the things which we are basically getting it from the actual documentation summary, right. Now now let us pass the additional context. So see, we are passing this additional context, so we have an additional prompt where we say, right, use this particular piece of information and then give the response, right. So now again we basically run this one. So once you run this one, you will see a clear difference on what is being given, like what is that it has been given earlier versus now. So now if you see here, right, see, now it has given a plan, but this plan is more towards this one, right. So if you see here, you will have under business requirement, the section will be there. See, step one, understand your business needs, right. So you could see similar data, right, or similar step by step summary, right. Now you can ask me, right, this can be done even in normal Python, why do we need Databricks, right. That is where we have another one option, which is the ML flow. So the ML flow also, as you know, right, this is a library which is built in Databricks, right, built by Databricks open source, which allows you to log your Databricks model experiments. Initially it started with normal data science models, but now they have extended for these frameworks as well, right. So now we have basically when you see initially, right, when I pass it, right, it gets it in the response, right. If you see here, right, it is giving only the summary, right, but we have the whole data not in summary, right, the content column. So you also need the other columns, right. So for that, what you will have to do is, right, you will basically, if you see here, right, we are basically, what we are doing here is, we are basically giving that columns as additional argument to the vector search. So this will give me also the other metadata columns, right, which we added. Now if I retrieve this, right, so you will see the difference. So without ML flow, right, you did not see anything, right, but with ML flow, if you see here, right, you could see the complete flow, what are the input passed, what are the documents. So you can click on this document, it will show you the whole document, right. So you will have the whole response from the vector DB, which is basically stored here, right. And again, right, since it is logged, you can go to, if you want to later come back, right, as part of the development cycle, go to experiment, and once you click on experiment, right, so under experiment, see, you have all the things, right. So this testing rag application, right, this code is there, and whenever an LLM is called, so you will see day by day, right, how many tokens are generated, what is the output token count, all these things are logged, and if there is an error, right, everything is logged here, right. Now you will go to basically, now if you see the response, now see, this is a complete response. It not only get the vector content, but it also get the additional data, right. Now let us pass this entire thing, right, to the LLM, right. Now if you remember earlier, right, we have seen that, okay, let me check, okay, I think I have to combine the response and metadata, so I'm just combining that, and once I pass this document, now you will see here, you will see here, right, now if you see, this is the output which is coming, right, and if you see the output, right, you will get the complete plan. And if you see again here, right, you could see, right, it stopped at middle, right. So how do we get that? So you can check for other thing, right, input attributes, and then events, right, all these things are there. So key thing is on the output, right, you can basically get, right, see the completion tokens, right. So it uses 3000 tokens, but in the completion rate, it only gave 250 tokens, right? And it stopped there, right? It did not execute fully, right? So what did we do? So I have reinitiated the model again, right, with the maximum amount of token. This 4096 is the maximum token, and I'm rerunning the entire process again, right? So once I rerun this process, I think it is taking some time. Yeah, I think it came now. Okay. If you see now, right, this is more of a complete response, and it exactly gives you, right, the complete summary, right? Understand your business need. Choose a process that prepare the disaster recovery, fail over to secondary region, right? Recover procedure, test, restore back to primary region, replicate the data, and then test and declare primary region operational. So you will see exact same set of steps here. If you see here, right, but it is having lot of content, right? But here it basically chunk the content and it will give you a precise set of instructions, right? So this is the LLM. So to recap, we use LangChain. We first created a vector DB. We had the chat Databricks. We asked the question initially, and it gave some random response without proper context. And then we added the RAG vector DB, and with that vector DB, we created a prompt, and then we provided that input. Once we have that, we basically were able to get the response, and we used ML flow. So once you give this import ML flow log, it will log all the LangChain based activity, like say querying the vector search using LangChain, or your querying the model using LangChain, right? All these will be nicely like it will be logged into ML flow, and it will be rendered very good. So you can have the details on how many tokens were passed, what is the input token, what is the total token. Right? It will ensure in terms of casting and other things, right? You will get the complete tracing, debugging things, right? Now, finally, right, we need to deploy this LLM, right? So for deploying this LLM, say let's assume, right, we have this flow where we first call a rag, and then we basically want to provide an answer. Right now we have created this flow. Now we need to have a API endpoint, right, which can serve this customized API, right? So for that, first what we have to do is we have to basically deploy that custom model, right? So for deploying the custom model, see, again we are doing the same thing. So you have to install the libraries and all these stuff, and it's the same prompt, right, whatever we have created there. So once you create the prompt, right, and then once you have the response, right, if you see here up to this it is same, we have created the response, right? Then finally we have a two-step process. First of all, for registering this ML flow, right? I mean, registering this model, right, and have a serving endpoint like a REST API interface, you need to basically have a two-step process where first you have to register with ML flow, and then register that ML flow model to Unity catalog, right? So once you have the code ready, you have to create a Python file. So this is the Python file where I am using the Databricks model, and then I'm basically having some queries and then some of the things. And finally, once you have the model ready, you have to use add this final line, right? So this is the retrieval bot, right, which I created using the retrieval chain LangChain library, right? So this retrieval chain library is again a thing which we did in the previous step, right, where we had a two-step process, right? Initially I had the prompt, and then I mean initially I have a vector search, and that is passed as input to the prompt of the LLM, right? So instead of that, we have this retrieval chain. That retrieval chain will combine those steps. So if you see here, right, we are basically directly chaining the vector store. So if you see here, right, this is the retriever is that vector store. So we are chaining the retriever response, the response from vector DB, and then combining that to the second question which the user is asking, right? So once you create this file, then first step is you have to register with ML flow. So for registering with ML flow, we need to have this code. So this code will basically where we are passing, we have to log the model. We are passing the code path which has the code. And how does MLflow know, right? Which is the final model it has to basically pickle and then serve, right? So you are setting the set model where you will set the LangChain final chain name, right? So once you have this deploy custom model, so you will basically have, and wherever resources you are using, right? So we are using Databricks resources like the Llama model and then the vector DB, right? So this you have to add. Then we have to pass a input, right? Say for example for this LLM, right? If you see here, we have to pass a dictionary with the invoke method. So that dictionary we have to give the format, right? So LLM, this ML flow, right, will basically register the model and then it infer the signature with this example. So it will expect the input to be like this format, okay, like a dictionary, right? Then what you will do is once you run this command, you will get the ML flow run ID, right? And then you are, let me see if I can run this again. I think should be, yeah. So, but if you see here, right, it will give a ML flow run ID and a model URI. So, this will give you that model which is hosted. So, once you get this ML flow model, right, then if you see here, right, we have to test the model, right? So, assume we have logged the model, right, and you got the model ID, right? But yeah, I think. I have changed the path to a different path. But let's assume, right, this is the model which is basically hosted, right? So which you got the URI. So now what we are going to do is, see, we are not going to run the original Python code. Rather, we have the MLflow model, which is a pickle file. So that model we are basically loading, and then we are asking the same question which we asked from the original thing, right? So what it does, basically we are trying to package the whole LangChain flow, which has two steps basically, right? Your contextual vector DB and then the prompt to orchestrate the whole process, right? So all those are pickled in a model. And once this model is basically deployed, I mean, like once the model is deployed in ML flow, you will have this over here. So here you can basically search for LangChain. I think it should be somewhere. Yeah, LangChain agent, right? So what it does, basically it will get your pickle file and it will store the data. So if you see here, right, it will have the if you see here, it will have the artifact. So what is there in artifact is basically it will have your code. It has the requirements.txt for all the libraries which it is using internally, and then it has this Python code. So basically what it does is it is trying to package your code and then deploy it as a service, right? So once this is added, right, you can also tag it and you can version it and you can deploy multiple times to have multiple versions of it, right? You can do all the CI/CD flow for your LLM application, right, using this model like ML flow. Once you have this ML flow, basically have this model, right? Then you have to register it with Unity Catalog. So once you have this in a ML flow, right, then you have to register that to the Unity catalog, right? So for registering it with Unity catalog, you need a catalog name, schema name, because for serving a model, you need a model inside your governed by UC. So for that, we are setting that and we are passing the model URI and then your model name, right? This is the same name, LangChain agent. Model URI is the URI which is deployed already, right? So once it is there, you have this in catalog, right, along with your normal workspace and your tables, you will have a model. So this model can be served. So for serving the model, you have to basically click on this serve. So once you click on, 1 minute, yeah, once you click on serve, you will get the details like endpoint name, all these things you enter. And once you enter, what you will get is you will get something like this. If you see here, this is a custom agent which is tailor made, right, which can be called as a REST API. So if I go click on use, if I give me steps for doing disaster recovery Databricks. Moment I click this, Basically, now we have a LLM based application packed very well, neat, and serving as an API, right? And you can serve it through Python curl, right? So if you have a front end application like a chat application, right, you can just integrate this endpoint, and then you can get the response for the user, right, for their questions. And you can pass the additional context also. Say you can have the front end layer where they ask multiple questions, you can summarize those questions and then add it here. So if you see here, right, this is the response which it gave, and you should see here, right, this is the final response which it has given. And see, so we are able to successfully pack a model and then give a response to it, right? So and you could see it is all logged here, right? Your API, everything is logged, and the response is also pretty much neat. So let us see. So yeah, I think that's all I had for this demo, right? So we could see, right? So you could see how to create a serving endpoint from a LLM, right? I think these are simple, right? You just have to set up these, and then that's all. Like once you create the serving endpoint, you can serve your apps, right? Like your front end apps with LLM. Okay, let me summarize the video. So I we test started with testing the LLM, and we see how did we use ML flow to log the things, and finally we deployed a custom agent. First we have to register with ML flow. For register with ML flow, we have to use the ML flow log model, and we have to pass all the parameters, path everything correctly, along with the resources which we are using, and we have to give an example so that it can infer the schema. And once a model is registered, then you have to register with Unity catalog. Once it is registered with Unity catalog, you will go to that catalog API, and then you will basically host the model. Once you host the model, you can make a LLM call, and you can get a customized response, right? So thanks everyone. Do share, like, and subscribe.